Welcome to your hands-on journey in data mining using Python. Data mining with Python, Retail Sales Dashboard, Week 1 to 2. Welcome! In this course, you will explore essential data mining concepts using Python. What is data mining? Data mining means discovering patterns within data. It is used in business, health, government, and more. You will learn by working with real datasets, like retail supermarket sales, Titanic survival, and Airbnb listings. This week, build foundations for your own interactive sales dashboard. Running the cell now. Let us get started with real data. We will start by turning off warnings so our outputs are easy to read. This step keeps our notebook outputs tidy by hiding unnecessary warning messages. We import the warnings module, then ignore all warnings. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This code sets up a clean and controlled environment by suppressing warnings and fixing the random seed, ensuring that any random processes produce the same results every time. This step is crucial in data mining to maintain consistency and reproducibility when exploring retail sales data. Although there's no visible output, it lays the foundation for reliable analysis in the upcoming lessons. Great! Now future outputs will be easier to follow. We will load the supermarket sales dataset to begin exploring retail data. We import pandas for working with tables and data. We provide the link to the supermarket sales dataset. We use pandas to load the dataset from the web link into our notebook. Our data is stored in a variable called df for easy access later. We print the number of rows and columns so we know the size. We preview the first 3 rows to see what the data looks like. Running the cell now. Here, the dataset contains 1,000 rows and 17 columns, showing a variety of sales details from a supermarket. Notice key columns like city, customer type, product line, and total, which provide insights into where and what customers are buying. This initial view sets the stage for mining sales patterns, helping us understand the dataset structure before deeper analysis. This small preview helps us see the column names and some typical values. Let us look closer at what this supermarket dataset contains. What is in the supermarket sales data? Each row is a single transaction at a supermarket. Columns show information like branch, store location, date and time, product line, customer type, gender, total sale. We will use this data to practice cleaning and basic analysis. Running the cell now. Exploring real transactions makes learning more meaningful. Before we dig deeper, let us print all the column names in our table. This prints out the full list of column names. It helps us see what information is available in the data. Running the cell now. This output lists all the column names in the supermarket sales dataset, giving you a clear overview of the different types of information recorded for each transaction. Notice key columns like branched to identify store locations and the total to see the transaction amount, which helps us understand the structure of the data before diving into analysis. This step is essential for planning how to explore and manipulate the dataset effectively. Take note of columns that sound interesting or important for a retail dashboard. Now, let us check the size and types of all columns. The .info method gives us quick details about the dataset. We can see how many entries, which columns are strings, numbers, or dates, and if there is missing data. Running the cell now. This output shows that the supermarket sales dataset contains 1,000 transactions with 17 columns providing details like store branch, product line, and payment method. Notice all columns have complete data with no missing values, and data types range from objects, for categories, to numeric types for prices and ratings. This confirms the dataset is well structured and ready for analysis of store performance and customer behavior. Knowing column types and missing data is key before doing any analysis. Missing data can cause problems. Let us check how many missing values are in each column. This counts the number of missing entries in every column. Spotting gaps early helps us avoid errors and plan how to handle them. Running the cell now. This output shows that there are 0 missing values across all columns in the supermarket sales dataset. This means every transaction record is complete, which is important for accurate analysis. Confirming no missing data ensures our subsequent steps, like exploring sales by branch, are based on reliable and full information. If there are missing values, we can decide how to fix them later. Let us convert the date column to an actual date type so we can use it for plotting or grouping. Dates in text format are hard to process, so we turn the column into a pandas datetime type. This change lets us group sales by day, week, or month easily later. Printing the new type confirms the conversion worked. Running the cell now. Here, we converted the date column to a datetime format, confirmed by the output datetime 64, NS. This ensures that all transaction dates are recognized as date objects, which is crucial for accurate time-based analysis in our supermarket sales data. Recognizing dates properly allows us to sort, filter, and aggregate sales over time effectively. Always make sure any date columns are in date format for easier analysis. Sometimes column names have extra spaces that break code. We will remove any leading or trailing spaces. We clean up our column names just in case there are hidden spaces. Clean names prevent typing mistakes and bugs when analyzing data. Running the cell now. This code snippet standardizes the column names by removing any leading or trailing spaces, ensuring consistent access to columns like branch. Although it produces no visible output, this step is crucial for preventing errors in later data selection and analysis. Cleaning column names prepares the data for accurately exploring supermarket transactions by store location and other key features. Simple cleaning steps now save you hassle later on. Let us get some quick stats for all the numeric columns in our data. This displays average values, minimums, maximums, and more for number columns. It helps us spot outliers and understand sales distribution. Running the cell now. This summary shows key statistics for numeric columns in the supermarket sales data, such as unit price, quantity, tax, and total per transaction. Notice the consistent count of 1,000, confirming no missing values, and how values like quantity range mostly between 1 and 10, reflecting typical purchase amounts. This quick overview helps us understand data distributions and informs next steps like filtering or visualization. Try to spot any numbers that surprise you or CMOD in scale. Understanding what stores and product lines are in our data helps us plan dashboard charts. We print all the store locations in the dataset. We also print the types of product lines being sold, like food or electronics. Running the cell now. The output reveals that there are 3 unique supermarket branches labeled A, C, and B, showing the different store locations recorded in the data. Additionally, it lists 6 distinct product categories customers purchased, highlighting the variety of items tracked in each transaction. This helps us understand the scope of the dataset and sets up for analyzing sales patterns by store and product line. Lists like these let us create drop-down menus and filters later. Let us visualize sales over time with a simple plot. Let us make our first sales plot. We can quickly see how sales change by day using a line chart. Charts are great for finding trends you can show others. Running the cell now. Visuals can make insights jump out. This code creates a line plot to show total sales for each day. We import matplotlib for making plots. This is a comment explaining that the next lines calculate total sales per day. We group the data by date and sum the total sales for each day. We set the figure size to make the plot wider and easier to read. We plot the daily sales as a line chart. We label the x-axis as the date. We label the y-axis as total sales. We add the titles total sales per day to the chart. We adjust the layout to improve spacing and prevent overlap. Finally, we display the plot on the screen. Running the cell now. This line chart shows the total sales aggregated for each day, making it easy to spot trends over time. Notice the overall shape of the line, rising or falling, which helps us understand how sales performance changes daily. This visualization confirms that grouping and plotting sales data by date is a powerful way to communicate key business insights quickly. Try changing which sales column you plot, or look at one store or product type. Bar charts are another way to compare stores quickly. We add up sales for each branch or store location. A bar chart helps us visually compare total sales by branch. We label the chart and adjust colors for clarity. Axis labels and title explain what is being shown. Layout is tweaked for easy reading. Finally, we display the bar chart. Running the cell now. Here, the bar chart clearly shows the total sales for each branch, making it easy to compare performance at a glance. Notice the different bar heights correspond to each branch's sales sum, highlighting which branch sells the most. This visualization helps us quickly identify key sales trends across branches, supporting smarter business decisions. Which branch has the highest sales? Try plotting product lines next. A pie chart lets us see which product categories earn the most. This comment explains that the chart will show a pie chart of sales by product line. We group the data by product line and sum the total sales for each group. We plot the summed sales as a pie chart, showing percentages and setting the figure size to 6 by 6 inches. We add a title to the chart to describe what it represents. We remove the y-axis label to keep the chart visually clean. We adjust the layout to ensure the plot elements fit nicely within the figure. We display the pie chart. Running the cell now. This pie chart shows the proportion of total sales attributed to each product line, making it easy to compare their relative contributions at a glance. Notice how each slice represents a different product line's share of overall sales, highlighting which products are driving the most revenue. This visual connects to our lesson by demonstrating how simple plots can summarize key business metrics effectively. What products seem most important for this store? Now it is your turn to experiment with the supermarket sales data. Practice, explore data yourself. Try creating your own charts. Plot sales by customer type or gender. Group by month instead of day. You can use df.groupb, .sum, .mean, .count. This practice will help you get familiar with Python data tools. Running the cell now. Pause and try one chart now before going further. Here is one possible solution for analyzing sales by gender. We group transactions by gender and add up total sales. A bar chart shows if sales are higher for men or women. Custom bar colors help make the chart easy to read. We provide a title so viewers know what the plot shows. We label the y-axis for clarity. The chart appears now. Running the cell now. This bar chart shows total sales grouped by gender, highlighting differences in spending between male and female customers. Notice the relative height of each bar, which reflects the sum of all sales for that gender, helping you see which group contributes more to revenue. This connects to the lesson's goal of practicing data exploration by grouping and visualizing sales across different customer categories. Try customizing the calculation to look at average sales amount instead. Let us wrap up with a peek at what is coming next. Next steps, get ready for streaming dashboards. You have learned how to load, explore, and visualize supermarket data. Coming up, make interactive dashboards using Plotly and Streamlit. Next time you will learn to build web apps from this notebook analysis. If you enjoyed, subscribe to the channel and practice these skills with new datasets. Running the cell now. Keep practicing with this data or try the Titanic or Airbnb datasets next.